We got two storage elements now. And there are three possible circuits. Okay, so now we have two storage elements. Which implies that you could get the RLC, the RCC, or the RLL. So it's one of those three circuits that we will be looking at. And as you're going to find here, is that the natural, that the complete response will have a natural response plus a forcing response. It turns out that the algebra involved in this chapter is considerable. And because it is so considerable here, I will not deal with time-dependent sources. I'm always going to assume, we're always going to set X forcing response to a constant. Okay, I'm just going to set it to a constant. I am not going to do anything like we just did on a second order circuit. The algebra is just too much. And so what I'm going to do then is that you're going to see that the natural response is now broken up into three pieces. You're going to see that, that this natural response, it comes in three flavors. And what I mean by that is that I know that in your course in differential equations, you talked about overdamped, underdamped, and critical damping. This alone produces a lot of algebra right there. And as we get a little bit closer to starting to look at the natural response, I'll go into detail and I'll start looking at how models of a mass spring system really show this behavior quite well. And then we can immediately apply to the circuit. So that's the reason why we're doing this. It's because the natural response has a lot more gusto to it than what we saw before. Now, if you look at the overall strategy of how we solve these circuits, you're going to see that there are really sort of like 5 main steps. And they're going to look, and they look very similar. So there are, 5 different steps for problem solving strategies. And the first one, which you want to be very well aware of here, is that you got to determine the second order circuit. Okay. You got to be real careful with that first step. You got to get that right. And then what we're going to do here is that, of course, we'll always check, our equation using, t going to infinity type of thing, as we did before. So we definitely want to look at that. And then you'll see here is that to determine, now that we already know what the forcing response is, because it's going to be a constant, you'll see it's very similar to what we did in Chapter 8. Our next step here is to do what? We want to determine the general response. And when we go determine the general response here, you're going to see it's the natural response that we're going to focus on. Right? That's a constant. So we now focus on this. And you'll see that we'll ultimately have to solve a quadratic equation. We got to go in, look at the quadratic equation, and determine whether it's over-damped, under-damped, or critically damped. And then each of these has a particular response. And then from here, we're going to go to step 3 here, and now we have a chapter 7 problem now. And in chapter 7, what did we do? We determined the initial conditions for the circuit. So that means that in order to solve for those arbitrary constants, there's 2 arbitrary constants, A1 and A2, but we're going to have to go in and find either this, well, we'll have to find these for certain, and then we're probably going to have to find this guy and this guy as well. So we could have to find up to 4 constants here in order to solve for those 2 arbitrary constants. And once we do that, that's a step all by itself. This is literally right out of chapter 7. And then when we go to the next step here, we want to then determine constants A1 and A2. And then finally, we get step 5 here where we solve the circuit problem. So when you're looking at these problem-solving strategies, note that these guys look very similar to the end of chapter 8. It seems kind of nice that, well, we got 2 constants instead of 1 that we got to go after. But everything's increased by a factor of 2. And you'll see, I'm going to go through step 1 right here, and step 1 has like 5 steps all by itself. And if you look at my equation sheet, the very first step just says derive second order equation. I don't give you these steps. And so when I go through step 1, one of the things that I really want to get you to try to do here is don't get stuck on the equations, like the step-by-step process. I'm going to outline a step-by-step process. What I really want you to focus on is thinking KVL, KCL. And just try to get methodical and look at the whole picture. Don't try to memorize a process. It's almost like an intuitive feel that I want you to go after. And we're just using straight up KVL, KCL, and just finding that sequence that works. Okay, even though I'm going to list lots of equations here, or steps, note, that's not what we're after. I'm putting these steps into detail right now so that you could follow me initially. But when you go to solve this equation, what I'd like you to do here is to literally take all those steps that I told you about and move them aside and just go by the intuitive feel of KVL and KCL. It will come way more natural. People who do that don't mess up on the equation. People who try to memorize the steps will screw it up in the end. So try not to do that.